Question number 1. We are given fx. Fx equals x squared minus 2 times 1 plus lambda x plus 4 lambda plus 3. Lambda is a real number, right? So for the roots of fx equals 0 are in opposite signs, that lambda less than minus 3 by 4, right? Fx equals 0 roots to be in opposite signs are, right? Fx equals 0 equation, let's see what is that. Fx equals 0. We get x squared minus 2 times 1 plus lambda times x plus 4 lambda plus 3 equals 0. This is the fx equals 0 equation. Now we'll assume the roots of this as alpha and beta. Okay. Then right. First one you can write alpha beta product constant term 4 lambda plus 3 divided by x squared coefficient 1. Okay. Right. So then asking what the alpha beta in opposite signs. When alpha and beta in opposite signs, when alpha is positive, beta should be negative, and the other way. Right. If alpha and beta in opposite signs, alpha beta product should be negative. Right. Alpha beta product should be negative. Right. Then you can write when alpha and beta are in opposite sign, right? Alpha beta product should be negative, right? Alpha plus beta we can't say anything because alpha plus beta can be positive or negative. That we can't definitely say, but we are sure that when alpha and beta in opposite sign, alpha beta product is negative. Alpha beta product is here 4 lambda plus 3 should be negative. This gives lambda less than minus 3 over 4. Okay, right. Here 5 marks given for this, right? 5 marks for this. For the answer, 5 marks. Next one, show that for all real values of lambda, the roots of the equation fx equals 3 are real. Let's see what is the equation fx equals 3. Fx equals 3. Fx equals 3. Fx is this. X squared minus 2 times 1 plus lambda times 6 plus 4 lambda plus 3 is fx equals 3, right? Then we can simplify here. 3 and 3 you can cancel down. Then we get x squared minus 2 times 1 plus lambda times x 4 lambda equals 0. Equals 0. All right. This is what we get. Right. You know, we need to show of this equation roots of this equation real. Right. So we will find the delta. Delta means this is your b. B squared minus 4ac minus 2 1 plus lambda b squared minus 4 times a is 1 c 4 lambda, right? So when you simplify this, we get delta minus 2 squared is 4 1 plus 2 lambda plus lambda squared minus here 16 lambda. Then take 4 out from this. Then we get lambda squared, right? And here minus 4 lambda minus 2 lambda plus 1. So you know this is really lambda minus 1 perfect square 2 times lambda minus 1 perfect square. All right. Okay. This delta. But you know, since this is a perfect square, this should be either greater than or equal to 0. Right? Delta greater than or equal to 0. This says delta greater than or equal to 0. When the delta greater than or equal to 0, you know the roots of the equation are real. Then you can write, therefore the fx equals 3, roots are real. Therefore, roots of fx equals 3 are real. Right. Here for this 5 marks, write in lambda 5 marks. Simplifying and come into this place 5 marks. Final statement 5 marks. Right. Next one, third part. If lambda 1 and lambda 2 are the two values of lambda, so that fx equals 0 has coincident roots. Fx equals 0 has coincident roots, right? Fx equals 0 means again that x squared minus 2 times 1 plus lambda times 6, 4 lambda plus 3 equals 0. Right. Here, lambda 1 and lambda 2 are the two values of lambda, so that the equation fx equals 0 has coincident roots. Coincident roots, for coincident roots, you know, delta should be 0. For coincident roots, delta should be equal to 0. Right. Delta mean now here b squared minus 4 times a, this should be equal to 0, right? When you simplify this, here minus 2 squared 4, that 4 and this 4 you can cancel down. Then we have to square this 1 plus lambda squared plus 2 lambda minus 4 lambda plus minus 4 lambda minus 3 equals 0. Okay, so when you simplify this, we get lambda squared minus 2 lambda minus 2 equals 0. This is the quadratic equation of lambda. So we are given in the question lambda 1 and lambda 2 are two values of lambda, so that the equation fx equals 0 has coincident roots. When the equation fx equals 0 has coincident roots, this kind of quadratic equation in lambda we get, then its roots should be that lambda 1 and lambda 2, right? So then we can write roots of this equation should be roots of this equation should be, right, should be lambda 1 and lambda 2. Roots of this equation should be lambda 1 and lambda 2, right? Then we can write sum of the roots lambda 1 plus lambda 2, and product of the roots we can write lambda 1 lambda 2, right? So this is 2 and minus 2. Right, now asking lambda 1 minus lambda 2 difference asking, right? That you can write lambda 1 minus lambda 2 difference you can write. First we'll write lambda 1 minus lambda 2 perfect squared. This you can write lambda 1 plus lambda 2 perfect squared minus 4 lambda 1 lambda 2. This way you can write it. Okay, then you can write lambda 1 minus lambda 2 perfect squared. Lambda 1 plus lambda 2 is 2. 2 squared minus 4 times lambda 1 lambda 2 minus 2. Here we get 12 as the lambda 1 minus lambda 2 perfect squared. So then lambda 1 minus lambda 2 we can take plus or minus, right, 2 root 3, right. Now we need the modulus of this. Take the modulus, then lambda 1 minus lambda 2 modulus going to be modulus of this is 2 root 3. Okay, right. So then the marks come in here. For coincident roots, this is 5 marks. Write in delta, substituting here 5 marks. Getting this quadratic equation 5 marks. Write in this 2 for both 5 marks. Write in this 5 marks, and taking this 5 marks and final answer 5 marks. Right, the last part. Find the values a and b in terms of lambda, so that fx equals x minus a perfect squared plus b. Find the value of lambda such that fx has minimum at x equals minus 2. Find also the minimum of fx at this value of lambda. Right. Yes, we are given fx this way. Fx is equal to x squared minus 2 times 1 plus lambda x plus 4 lambda plus 3, right? Now we are going to complete the square of this. Fx, we know the steps in completing the square. Put the perfect square of x squared, we put only x, minus, divide this by 2, 1 plus lambda, then 4 lambda plus 3. The perfect square of this we have subtract now. This is the complete the square. Okay, now we can furthermore simplify this. We get fx equals x minus 1 plus lambda perfect squared. When you simplify here, we get minus 1, then 2. Here minus 2 lambda plus 2 lambda minus lambda squared. We get like this. Okay. Now we can compare this with x minus a perfect squared plus b. We need to find this what? Find the value of lambda such that fx has minimum, right? Find the values of a and b in terms of lambda. Yeah. Now you can clearly compare. The place of a you have 1 plus lambda. Place of b you have 2 plus 2 lambda minus lambda squared. Okay. Right. So then here for the step this 5 marks given, and come in here another 5 marks, and given for a and b in terms of lambda, here 5 marks and here 5 marks, right? And find the value of lambda such that fx has a minimum at x equals minus 2. Right. Minimum occurs at x equals minus 2. Right. You know, when we have something like this, the minimum value of fx occurs at x equals a. Then you can write there minimum value, minimum occurs at x equals a, right? When we have this way, right? After completing the corollary function, minimum value occurs at x equals a, that we learnt in the theory class, right? But we are given the minimum value of fx occurs at x equals minus 2. Okay. Then this x should be minus 2. But we know a 1 plus lambda put here. Then we get lambda minus 3. Right, this is 5 marks. Okay, next one asking find also the minimum value of fx at this value of lambda. Minimum value of fx going to be, right, this b. Minimum value of fx, that is this. Now we need to find the value of this b when lambda is minus 3 years. Then fx minimum you can write the last answer, fx minimum is therefore substitute for this lambda minus 3 to here minus 6 and 9. Then we get minus 13, no? Right. For this we get 5 marks. That is how we complete that first question. Next one, question number 2. Okay, question number 2. Show that the remainder when the polynomial fx is divided by x minus a is FAR, right? So then you can write question number 2, right? Okay, you can write let capital R be the remainder, when fx is divided by x minus a. Now we can write by algorithm of division. By algorithm of division, you can write what? Fx is equal to x minus a into 5x plus r. This way you can write. Okay. Now we can put x equals a. Here we get fa, here 0, r. Therefore the remainder is fa, right? Then you can write therefore remainder is fa, right? For this we get 5 marks, algorithm of division, right? And remainder is fa, this we get 5 marks, correct now? Okay, next one. Show that the function fx has no factor in the form x minus k, where k is a real constant, right? Where k is a real constant. Okay, right. You are given fx. Fx given this way, fx is equal to x4 minus 2x squared plus 6, right? Ask me show what? show that the function fx x4 minus 2x squared plus 6 has no factor in the form x minus k. Alright. Now we substitute x equals k here. When we put here x equals k, we get fk, k to the power 4 minus 2k squared plus 6. No. When there is a factor for this fx in the form x minus k, then this fk should be 0 according to factor theorem. Understand? Then now we are going to show this fk cannot be 0, never be 0. Alright. Fk never be 0, right? So then we can simplify it like this. Here complete the square of this. From k to the power 4 take only k squared. Divide this k squared coefficient by 2, we get minus 1. Take the power of x squared. Then 6, 1 squared is 1, minus 1. Then when we simplify this thing, we get this. Then we get k squared minus 1 power of x squared plus 5. It is our fk. Okay. Alright. Now we can see this is not equal to 0. Really, no? This is a perfect square, no? Even though this is perfect square, now the plus 5 is there. Therefore, the sum not equal to 0. Therefore, fk not equal to 0. Fk not equal to 0 means, right? X minus k cannot be a factor, no? Right. Then you can write, therefore, fx has no factor in the form, fx has no factor in the form x minus k. Okay, right. Then here, showing this, we get 5 marks. For the statement, this 5 marks. Right. What is next? Given let gx 3fx lambda x squared plus mu x. If x minus 1 and x minus 2 are factors of gx, find the values of constants lambda and mu. Hence, factorize gx. Right. Define gx this way. Gx equals 3fx plus lambda x squared plus mu x. Right. Okay. Right, now I can write fx, substitute for fx. Fx is x4 gx. Now we can write 3 times, substitute for fx. Fx is x4 minus 2x squared plus 6. Okay. Right. And lambda x squared plus mu x, no? Right. Then we can write gx 3x4, and here we can write, yes, minus 6x squared plus 18 lambda x squared plus mu x. Right. This is gx. Right, now given if x minus 1 and x minus 2 are factors of gx, if x minus 1 and x minus 2 are factors of gx, then g1 should be 0 and g2 should be 0. Correct, no? Why? According to factor theorem. Right. G1 0 means what? Substitute x equals 1 and take one equation. G1 0 we can write here 3, here minus 6, right? Right. Here 3 minus 6, then here 15, right? Lambda plus mu should be equal to 0. Lambda plus mu equals minus 15, number 1. First equation. Here, secondly, g2 0. Put to here. Then once you put g2 0, right? Here for this equation we get 5 marks. G20 brings us 3 into 2 to the power 4 minus 6 into 2 squared. Put x equals to there, plus 18 lambda 2 squared plus mu 2. This should be 0, G2 0. Once we simplify this, we get 2 lambda plus mu equals minus 21. This is number 2. For this, we get another 5 marks. Right. Then by solving 1 and 2, you get for lambda minus 6 and mu minus 9. Right. These are the right values. So for this 5 marks, this 5 marks. Right. Then asking what? Constant lambda we found, hence factorize gx. Hence factorize gx means now let us write the gx. Alright. Therefore gx we can write. What is gx now? Substitute for lambda and mu here. The values we found. Then we get the gx as this way. 3x4 minus 12x squared. Right? 12x minus 9x plus 18. This way we get gx. Right. Now asking to find the factors of gx. Okay. Right. Now first I can take this 3 out. Once we take this 3 out, we get x4 minus 4 x squared minus 3x plus 6. This way we get right. Now we need to find factors of this. For this you get 5 marks. Right. Now here for this gx we are given 2 factors, x minus 1 and x minus 2. So then I can write this 3 times. This one I can write x minus 1, x minus 2. This is 4th degree one. So therefore the next factor should be 2nd degree one. Okay. 3 I kept out. For this only now I am writing the factor should be of this x minus 1 and x minus 2, because gx has the factors x minus 1 and x minus 2. The next factor should be 2nd degree polynomial. Since here the x to the power 4 is 1, here x squared coefficient 1 now, this should be x squared, right? Here minus plus 2, here we have 3, therefore we should have 3 here. So middle one we can find bx like this. Correct, no? The 3rd factor this way we can write. 3rd factor should be quadratic one, no? 2nd degree one, right? Now I can find this b. We need to find this b, right? Right, to find this b, put x equals minus 1, then we get g minus 1. 3, here first bracket minus 2, here minus 3, here 1 minus b plus 3. Right. Now g minus 1, right, I can substitute here. G minus 1 means putting here minus 1. What do you get? 3. Here minus 12, minus 1 is 9, plus 18, equals here 3, 6, 4 minus b. Okay. When you simplify this, you get the answer for b. B comes as 3. B comes as 3. Right. B is 3. Right. Okay, write in this way, 5 marks you get. And answer for this b, another 5 marks. Right. Another 5 marks. Then you know this b also. Therefore I can write gx. 3 times x minus 1, x minus 2, x squared plus bx plus 3. X squared plus bx. B is 3, no? 3x plus 3. This is the factor. Okay, this is a factor. Okay, people, you know, this is what? Quadratic expression, no? When you calculate its delta, what is delta? B squared, 3 squared minus 4 AC, 3. You know, this delta negative. This is a minimum graph because x squared coefficient is positive. Minimum graph with delta negative. That means no roots. Then this graph should be like this, no? Completely above x-axis. So you can very clearly understand that is forever positive. This is positive, right? Because delta negative, this is positive. Factors are this now of gx, this is obviously positive. Reason? Here x squared coefficient is plus, therefore the minimum graph. Since delta negative, no roots. Minimum graph without roots means graph should not cut the x-axis, it should completely above the x-axis. Alright. That part we need for the next answer, right? Okay, for this factorization, another 5 marks we get. Right. Now asking what next? Also find the range of x so that the function gx is positive. Range of x asking for the function gx to be positive. Gx greater than 0. Substitute for gx this 3 times x minus 1, x minus 2, x squared plus 3x plus 3 greater than 0. We said this is positive. This 3 also positive. Then for this product to be positive, x minus 1, x minus 2 should be positive. Okay. For this 5 marks. And now you can find the range of this. X equals 1 here, x equals 2 here. We don't have equal sign. Then circle at these places, but don't color. Okay. Zeros in this interval, put 0 here and here, we get what? Minus, minus, plus, then this satisfies. This does not, then this satisfies. Then we get the answer as x less than 1 or x greater than 2. This is another 5 marks. Right. It's question number part B, no? Right. Next one, part B, logarithm question. Yes, logarithm part. Okay, given this, solve the equation this. Part B. 2 log a to the base x plus log a to the base ax plus 3 log a to the base a squared x equals 0. Right. We know one logarithm rule. When I take this logarithm to denominator, these two numbers exchange the places. We know that. Then 2 is at the numerator, we bring this right denominator, then that going to be this way. Here also the same thing happens. Log axa. Here keep 3 here. Log a squared x here a equals 0. This way we can write. For this we get 5 marks. Right. Then here this one I can write as a sum. When we have product here, we can write as a sum like this. Okay. And here also you can write log a squared plus log a x equals 0. You know this is 1. You can bring this 2 before and then rest one is 1, therefore here we have 2. Right now? Then meantime we put let simple t equals log x to the base a. This way we use a substitution. Now here we have 1. Here we can bring this 2 before, then this is 1, then whole value here is 2. Right. Correct, no? Yes, we can bring this 2 before, no? This is 1, 2 into 1 is 2. Right, so then for this step also 5 marks come in. Now we can write this one as 2 over t plus 1 over 1 plus t plus 3 over 2 plus t equals 0. This way, another equation we get. Okay. Now we multiply this by what? We multiply by t times t plus 1 times t plus 2. We multiply this. Right. Okay. Then when we multiply by this factor, we get like this: 2 times t plus 1 t plus 2, right, and 1 times t plus 2, right, and 3 t plus 1 equals 0. This way we get. When you simplify this, we get 6t squared plus 11t plus 4 equals 0. 6t squared plus 11t plus 4 equals 0. Alright, for this we get 5 marks. Okay, now we can factorize this. Here the factors are, 2 factors we can write: 3t plus 4 and 2t plus 1 equals 0. T minus 4 by 3, t equals minus half. Right. 2 answers for t we found now. But t is this. Right. For this both answers 5 marks come in, no? Right. Now we substitute for this t. What? Log x to the base a minus 4 over 3. Then x can be subjected, take this a right hand side. X equals a to the power minus 4 by 3. For this answer, log this way we can write minus half. Then we get x equals a to the power minus half. Right? These are the 2 answers we get. Then we get 5 each. Right. Okay, next one, the question number 3. Question number 3. Question number 3. Y equals e to the power sin x, show that this answers. Right. y equals e to the power sin x. Right, first one, differentiate this dy by dx. First the derivative of e, then the same, then derivative of sin x cos x. Right, but this e to the power sin x is y now. Dy by dx is equal to y cos x. Right, this is 5 marks. Secondly, we differentiate. Taking this as u function and this as v function. When we differentiate this, we get second derivative d2y over dx2. Y cos x root is minus sin x. Alright, keep cos x as the same. Derivative of y is dy by dx. Then multiply this by y. Then we get y d2y over dx2 equals minus y squared sin x. Here y cos x dy by dx. We multiply both sides by y. But this y cos x is here. Y cos x means this, that is again dy by dx. Y cos x here. Right. So we get the answer, no? Then we get y second derivative, right? Bring this to this left hand side plus. Here dy by dx is dy by dx perfect square. We get y squared sin x minus dy by dx perfect square equals 0. This way we get that answer. And the marks come in here for this 5 marks, for this 5 marks, right, and multiply this by, right, 5 marks, this by y and getting this one 5 marks, and taking the final answer 5 marks. This 5 marks, huh? Right. Right. Okay, second part in it, B part. Part B, we are given fx 2x squared minus 4x x minus 3 x plus 1. Show that f dash x is this. Sketch the graph of the function y equals fx indicating turning point and asymptotes, not points of inflection. No need to find the second derivative therefore. Right. Okay, fx, we'll write. Fx equals 2x squared minus 4x minus 4x x minus 3 x plus 1 x minus 3 x plus 1. Okay. Right, now we have to differentiate this f dash x. You have to follow this, you have to take as we are u, this have to v, u upon v form, right, we have to follow. Right, we know how to differentiate this. R square is x minus 3, x plus 1 square. Same thing coming at the beginning. And multiplied by the derivative of this 4x minus 4 minus, then keep this 2x squared minus 4x, right. Now differentiate this product, right. To differentiate that product, don't go to use u into v product form. Remove the bracket, x and x squared, derivative is 2x. Here minus 3x, here plus x, minus 2x, derivative is minus 2. Minus 3 plus 1 minus 3, constant 0, right now, right this way. Okay, then here taking 2 out and multiplying that by this, we can form 4x minus 4 here. That 4x minus 4 and this 4x minus 4 common we can take out, huh? F dash x. 4x minus 4 we can take out. Right, so then here we get, alright, simplify this directly, x squared minus 2x minus 3, right. Here I took 2 out and put that here, then here we have minus x squared minus minus plus 2x. This is what we get there. Then denominator we have x minus 3 power of x squared, x plus 1 power of x squared, minus 2x plus 2x we can cancel down, this and this we can cancel down. Then take this 4 out, with this minus 3 we get f dash x, right. Okay, then we get 12 there, minus 12, x minus 1, divided by x minus 3 power of x squared, x plus 1 power of x squared, right. This is our f dash x. Then here we get 5 marks, here we get 5 marks, right. For the simplification another 5 marks, final answer another 5 marks. Okay. Right, now the rest part. Right, now we know here y function is known, dy by dx also just now we found. Y function given 2x squared minus 4x upon x minus 3, x plus 1, and dy by dx just now we found f dash x is that minus 12 x minus 1 x minus 3 power of x squared x plus 1 power of x squared, this way, right. Okay, now first we have to find the vertical asymptotes. For vertical asymptotes, this denominator we have equal to 0, x3 x minus 1, vertical asymptotes. Vertical asymptotes at x equals 3, x equals minus 1, right. And we'll take the horizontal asymptotes. For the horizontal asymptote, we have to take the limit x going to plus or minus infinity on the right hand side of this. Limit x going to plus or minus infinity, the right hand side. This right hand side, take x squared out with 2. Also take 2x squared out, 1 minus 2 over x divided by Here take x out, x squared out, then 1 minus 3 over x, 1 plus 1 over x. These two you can cancel down. Then we get, when you put infinity here, this is 0, this is 1, 0, 0, 1, 1, 1. Then we get, really, there, yes, we get 2, no? Yes. Y, 2, no? Right. Also doesn't what y equals 2. Yes, correct, no? 2, y equals 2. Right, no? 2x squared when you take out 1 minus 2 over x, correct. Okay, then here we get 5 marks for this, 5 marks for this, and for this simplification 5 marks. Getting the household asymptote as 2, another 5 marks we get there, right? Right. Next one, station points. At stationary points, dy by dx 0. Right, dy by dx is this. When this is 0, the numerator should be 0. Numerator we have x minus 1. Then x minus 1 equals 0, x equals 1. Okay? For this 5 marks. Right, now at x equals 1, we will find y. Because at x equals 5, put that 5 here, 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 then we get y. Y we get this way 25, 50, and t, x equals, sorry, not 5, no, x equals 1, no, not 5, x equals 1, x squared into 1, no, right. Then we get y half here. When you put x equals 1, we get y half. Then the station point is 1 comma half. Station point is at x equals 1, for that 5 marks given, and then put in that x equals 1 here, we can find y is half. Right, for the station point, another 5 marks come in. Okay. Now we have to prepare the table. In the table, we have to put x values at the vertical asymptotes and x values at the station points. Then they are minus 1, plus 1, and 3. Right. We prepare the table there. This way. Right. Minus 1, x1, 3. This way the table we have to prepare. Now we are supposed to find the dy by dx in each interval. Right. Dy by dx is this. Its denominator is completely positive. Therefore, its sign is given by the numerator. Right. X is then minus 1. When I put like minus 2, we get plus here. And here also plus. Between 1 and 3, like 2, minus. Greater than 3, also minus. Okay. Then here, what do you mean? Gradient positive means fx increasing, no? Fx increasing. Dy by dx positive means fx increasing. This also increasing. Here decreasing. Here decreasing. Gradient negative means graph decreasing. Gradient positive means graph increasing. Graph means fx. Right. For this we get 10 marks. For all the table including all this data. Now the final discussion part. Right, x equals 1 only we notice people there's a station point. The station point should have this shape, no? Positive, here negative, this is 0, then the station point is maxima, right? This is a maximum stationary point. Maxima we have. Okay? Right. Station point is maxima. Right. Right. At x equals 1, y is half. Y is half here. X equals 3 we have vertical asymptote. Right. Right, now the graph. Right, you know, when you put x equals 0 here, y 0, that means graph passes into the origin here. Right. And also, when you put x equals 2, 2 squared 4, 8 minus 8, again by 0. Cuts the x at 2 also, right here. The graph is now this way. It cuts the x-axis at 2 here now. Right. Also doesn't dot y2. You see now. Here too. For the graph 10, but you should find another one more. What's that? When y equals 0. That means I am finding these points. Huh? When y equals 0 means 2x squared minus 4x divided by x minus 3x plus 1, 0. What do you get there? X equals 0, x equals 2. X equals 0, x equals 2. Right. Okay, no? The 2 points we found. For this also 5 marks given. No? These 2 points. This is a sketch for the whole graph, 10 marks. Okay, next one, applied bench part. This question in the class we have done already. Yes. Okay. Yes. This question, since we have done, yeah, we'll take that question too. Right. Right now. Right, here initially we have the particle P at time t equals t. It turns through the point O by an angle theta. This is particle Q. Its mass is 3m, string like this. Tension T available here. This angle theta. Radius is A. The normal reaction this way R. The velocity along this direction going to be A theta dot. Theta dot is the angular velocity. Right. This in the another tension Tx. This is the particle P with mg. Normal reaction suppose S. Then this particle P also moving with the same velocity A theta dot. Right. I will take the potential energy 0 level as this level. Then initially this particle Q was here B. Right. Initially no energy for both A and B. Then we can apply conservation of mechanical energy. Right. Conservation of mechanical energy we can apply there. Right. Then there we have kinetic energy. First one, kinetic energy of P, half m A theta dot squared, half m v squared. Right. And the kinetic energy of Q, half 3m A theta dot squared. Right. And here potential is 0, but here this has potential energy negative. Right, this length we need. Whole length is A, this is A cos theta. Since that lies below, we get 3mg, right, this A minus A cos theta. A minus A cos theta. This is the total energy at time t equals t. This is the moment t equals t. But initially, both they didn't have any energy. 0. This is therefore 0. Marks come in this way. Write in this 10 marks, 10 marks, and here 10 marks. Okay, now multiplying this by 2 and cancelling down by m. Okay. We get that answer. Theta dot squared is equal to 3g by 2a 1 minus cos theta. Right. Theta dot means d theta over dt perfect squared. Right. 3g by 2a 1 minus cos theta. Right. For this we get 10 marks. Okay, next one asking Can you otherwise show the acceleration of the particle p? Acceleration of the particle p. Acceleration of the particle p. Acceleration means first derivative of the velocity, no? Right. Acceleration of p is equal to d over dt velocity a theta dot. Right? This is nothing but a d over dt theta dot. A d over dt theta dot means theta double dot. We need a theta double dot is the acceleration of p. Getting these 5 marks. Right. Now, over there we have theta dot squared as 3g over 2a 1 minus cos theta. Right. Now I am going to differentiate both sides with respect to time t. First we have to differentiate these two. 2 comes before 2 theta dot 2 minus 1 is 1. 2 theta dot. Multiplied by, now we have to differentiate this theta dot. With respect to time t, when we differentiate, we get theta double dot. Okay. Right hand side, 3g over 2a is a constant. Now go inside the bracket. It first we have 1 is a constant level of 0, minus, first differentiate cos. When we differentiate cos, we get what? Minus sine theta, then differentiate theta with respect to time t is theta dot. Okay. Then this theta dot, you can cancel out with this. Bring this a here and 2 where here. This gives us a theta double dot. A theta double dot is equal to 3g by 4. Correct, no? Bring this a here, 2 here. 3g by 4 here, sine theta. Okay? Alright. Here we get for the differentiation part, for this side 5 marks, this side 5 marks, and then this way, this is 5 marks. That is the expression of P. Okay, next one. Asking what? Find the reaction from the tube on the particle Q and the tension in the string at time t. Right. Right, now we can apply F equals ma for Q. Right. F equals ma, we apply this way for Q. What do you get? This is theta, no? 3mg cos theta minus r. 3mg cos theta minus r equals 3m. Centripetal acceleration is v squared over a. V means a theta dot, no? V squared over radius a. This way we get, Right, we'll subject r by this. Here we get for this 5 marks and here 5 marks for this. Right. Then subject r brings this side and this side, 3mg cos theta. Here we get 3ma theta dot squared. 3m a theta dot squared. R is equal to 3 mg cos theta minus 3m a T dot squared. T dot squared answer there we have 3g divided by 2a 1 minus cos theta. Right. A and a you can cancel down. Then once you simplify this, you get for this r the answer 3 mg by 2 5 cos theta minus 3. Right. Right. This step you can simplify, right? Okay. Here for this place substitution for the T dot squared 5 marks come in, and simplify and take this answer another 10 marks. Our last one is tension in the string at time t. If equals ma we can now apply. If equals ma now we can apply for p right third. There tension is t equals m times acceleration of p we found 3g by 4 sin theta. E theta double dot no. Right, and then substitute for this we get t, right, 3mg sin theta by 4. Here 5, here 5. Okay, you see, no, 10 marks coming for the final one. 10. Okay, question number 5 next. Okay, question number 5. Question number 5. So, okay, question number 5 says smooth hemispherical ball of radius simple A is fixed so that it remains horizontal and uppermost. A uniform rod AB of length 2L and weight 2W is in equilibrium with end A in contact with the inner surface and end B projecting beyond the rim of the ball with a weight W attached there. With the inclination of the rod to horizontal is theta. Show that this answer, right? Right, so now here see here we have a ball. Okay, this way rod is placed. Now here reaction going through this point, and the reaction here perpendicular to rod. We know they meet, at a point on the circumference that we know in theory class, no? Theory we learn, no? Right. I'll mark that reaction here. This way. R. Here the reaction should pass through point this, because the reaction here perpendicular rod like this. Right. Here 9. Then this is uniform rod, and here also weight is suspended. Right. Weight of the rod is 2W. At the end, B also simple W weight suspended. Right. Then the result of that W at B and weight 2W of the rod, these two will have the resultant weight 3W. When we take this resultant of 2W and W, this 3W, as single force, with these two altogether, now we have 3 forces. Then the rod is in equilibrium under the action of 3 forces. Therefore, they must meet in a point. So therefore, the 2W resultant 3W should then pass through the point this. That is the correct force diagram. You see, right? You see, right? 3W. Right, so here I take this as our B. At B, where W suspended, then here we have 2W, the weight of the rod. Right. Now, when we really draw horizontal line through the point this, that will pass through the point this. Listen. This is diameter. I draw horizontal line here. This is vertical line. This is diameter. This vertical line and the horizontal line, the angle between them is 90. Therefore, we must meet where at a point on the circumference. That also we know. This also we discussed in the theory class under cooperative forces lesson. Here should be 90. Okay. And we are given the length, the angle is theta to horizontal. If you take this as theta, this and this horizontal, this should also be theta. This length and this length being equal, therefore this angle and this angle should also be equal theta. And the radius of the ball is A, here, A. And we are given the length of the rod is 2L. And also it is a uniform rod. This is, right, L. The length from here to here, L. This is L. This is also L. Okay. Now, if I take this point as, right, G, I need to find this length. Right. Okay. You can very clearly notice here 2W and this W, their result node is 3W. Therefore, if I find the ratio, the length this is to this length. The result of this and this is this 3W. We learned in the theory class, when we have this way two parallel forces P and Q, the resultant is P plus Q. Then this length is to this length ratio, this P come in here, this Q come in here. That we have learned in covalent forces lesson. Yeah. Then here, this 2W represent this ratio, this W represent this ratio. Therefore, this is W is to 2W ratio. That means what? 1 is to 2. Yes, 1 is to 2. Okay. Then I supposed to find this length from here to here. Right? If I take this as G dash and this as G. Right. Now this GG dash length we can find. Right. Okay. GG dash length. How to find that? The whole length is from here to here L. That should be divided by 1 plus 2, 3. Then to take this multiply by 1. Right. Then we can write GG dash. GG dash whole length is L divided by 3 multiply by 1. Right. Right. For this diagram 25 marks given, but all this information must be there. Right. Otherwise you lose 5 marks for each. Namely, R and S must meet here. 2W you have to mark and resultant must be marked as 3W. The ratio 1 is to 2 here marked though. By that calculation we must get that idea. Right? This angle theta you have to mark them. This is 90. Including all this information only you get 25 marks. Right. Now we can write AG dash. AG dash means the length from here to here. Here A, this is B now. Right. AG dash means AG plus GG dash, L plus L by 3. L plus L by 3, this is 4L by 3. Okay. I'll take this point as D. This AD I can write in 2 ways. What? AG dash cos theta and A and A2A cos 2 theta. All the geometry we use there, right? By taking the forces and resolving horizontal, vertical and taking moments also possible to apply. Right. By the diagram we can write. By the diagram we can write AD. One way of writing AD is 4L by 3 cos theta. Other one, this AD, we can write here A, 2A, this is 2 theta, this is 90 now, 2A cos 2 theta. 2A cos 2 theta. Right. For this 5 marks, this 5 marks, this 5 marks, for this 5 marks. Then equate this 2, therefore 4L by 3 cos theta is equal to 2A cos 2 theta Then cancel down this and this by 2. 2L cos theta is equal to 3A cos 2 theta. Okay, right. For this answer, we get 10 marks. Find question in terms of L and A and show that the length of the part of the rod projecting beyond the rim is this. That means asking to find this part, small part, this length. Right. Okay. Now, by using this result we can write 2L cos theta equals right hand side 3A cos 2 theta. Cos 2 theta on the right hand side we can write 2 cos square theta minus 1. 2 cos square theta minus 1. Right now, remove the bracket 6A cos square theta. Right? Take this to the side, minus 2L cos theta. Minus 3A. Correct, no? We remove the bracket here, take this to the side. Now we must have left hand side 0, no? Put I put that this way. Right, here 5 marks, for this also 5 marks. Now what is this? This is a quadratic equation in cos theta. Right, cos theta minus b. B is this minus 2L plus or minus square root. B squared means minus 2L perfect squared. B squared minus 4. A means 6A. C minus 3A. Divided by 2 into 6A. Okay. Right, so now here this 4 here, so 2 squared 4, no, we can take out 2, that 2, this 2 we can cancel down. Then we get cos theta here plus L plus or minus square root L squared minus minus plus 18A squared divided by 6A. Right. But this theta is acute angle, therefore cos theta should be positive. If you select this minus sign, the numerator will be negative and cos theta will be negative. This is impossible. Therefore, we can write cos theta positive. Cos theta should be positive. Therefore, select the plus sign. Therefore, cos theta answer equals L plus square root of L squared plus 18A squared divided by 6A. For this 10 marks coming. And using this quadratic formula, another 5 marks. Right. Okay, next one. The length of the part of the rod projecting beyond the rim is this R, right? This one, this part, small part, this. What is the length from here to here? 2L. From here to here, this is 2A, this is theta, 2A cos theta. Right, 2A cos theta, right? Length projecting beyond the rim. Length projecting beyond the rim. It's 12 minus 2A cos theta. Right. 2A cos theta substitute here cos theta, L plus square root of L squared plus 18a squared over 6a. Okay, now simplify this. A and a you can cancel down. 2 and this 6, 3. Then we get common limit as 3 here. This 3 comes here, 6L minus L, 5L coming, minus that answer. Square root of L squared plus 18A squared. This way we get that. Right. So for this we get 5 marks. Substitute in here 5 marks and final answer 10 marks coming. Right. Last question next. Question number 6. Okay, number 6. Right, number 6. The points A, B, C in the xy coordinate plane given. Forces of magnitudes this way given. X on sides this. Find the magnitude and direction of the resultant force. Right. So here y. Okay, point A. Here we have point A, A0, point B, AA, point C, 0A. This way, right? Okay, the forces now act like this here. 4 here 1, here root 2, here 9 root 2, this is 3, here 2, here 90, here 90, here 90, here 90. This angle is 45, isn't? This is square, this length A, this length A, this length A. So square, right? 45, right? First one asking find the magnetic direction of the resultant force. Then we have to resolve the forces, right? Horizontally. Resolving horizontally, right? For the diagram given 15 marks. 15 marks given for this diagram. Right. Now, when you resolve horizontally, x we get 1 minus 3. 9 root 2 cos 45 is 9. Root 2 cos 45 is minus 1. Here, this is 45. Root 2 cos 45. Cos 45 is 1 over root 2. Root 2 and this 1 over root 2 we can cancel down. Right. That's all. Then we get 6. We get for this 5 marks, here 10 marks. Resolving vertically, y. 2 upwards for downward, 9 root 2 cos 45, 9 root 2 over 1 over root 2, root 2 cos 45, that also plus. Then there we get 10, 8, y 8. Now we need to find here 10 marks and this is 5 marks. Right. Now we need to find the resultant. X and y we know, y 8, x 6. Resultant force assume as R. Let the angle be alpha. R can be found how? R equals square root of x squared plus y squared. Right, x means 6 squared, y 8 squared. This is nothing but 10. Tan alpha can also be found. What is tan alpha? Tan alpha 8 over 6. 8 over 6, this gives us alpha tan inverse 4 by 3. Yes, here this answer 5 marks, tan alpha 5 marks, this. Okay. Now, what is actually asking? If the resultant force cuts the OX axis at N, find ON. Right. Resultant force cut OX axis at N given here. This is point N. Okay. Horizontal component of the force is 6 here, 8. This is alpha, tan alpha given by 4 by 3. So we can take moment around O. We can take moment around O. When you take moment around O, first take moments of the forces. Only this force give moment around O. That should be equal to the moment of this resultant. It's also this 6 we now pass into the point O, only 8 gives the moment. Yes. Then this length is 2 into A is the moment of this 2 and this is A, anti-clockwise moment, and 3A. and this root 2. Root 2 cos 45, that means 1. 1 into A is A. The moment of forces this much should be equal to 8 multiplied by O in. Okay. Then we get 8 O in equals 6A. O in is 3 by 4. Then the coordinates of n going to be what? 3A by 4 comma 0. The moment equation 10 marks given and ON answer 5 marks given. Now find the equation, asking to find the equation of the line of action of resultant. For that you can use y minus y naught equals m times x minus x naught. Okay. X naught, y naught. X naught you can take 3 by 4, y naught you can take 0. Gradient is tan alpha, 4 by 3. Y minus 0, tan alpha, 4 by 3, x minus 3a by 4. Okay. Right, for this 5 marks given. Okay. And now once you simplify this, you get the required answer. 3y minus 4x plus 3a equals 0 as the equation of the line of action of the resultant. 10 marks. Okay, the last part of the question. A couple on the plane of the force is now added to the resultant force. Passes through the origin. Find the magnitude and directions of this couple, right? Then this system of forces I can now mark like this. The resultant force 10 acting at n. N has the coordinates 3 by 4, 0. Right. Now I will take a moment G of a couple is added to this. Right? You know, a single force and a couple together form the same single force but acting at a new point. We usually say when we apply this moment of a couple to a single force, we say the single force displaces without changing the direction and the size, it only displaces. Then here also same thing happens. That system has single force 10 we found, that I marked here. To that system, this way a couple is added. Now we are given, because of this couple, this single force now acting at O. This single force and this couple is now equivalent to what? Another single force acting at O like this, of the same size 10. There you should know, once you apply a couple to a single force like this, only the single force displaces the position, not the direction or size change. Now this single force plus couple is same as this. Then we can take moment around O for both. Right. Right. Then we get what? We take moment around this anticlockwise. We know the moment we got anticlockwise of the system, this we found it 6a. Now another G come in anticlockwise. Alright. It should be now 0. Okay. Then we get G minus 6a. Right. Newton meters. Right. G is negative. We mark this G anticlockwise, but that is negative. That means clockwise. Then you can write magnitude of the couple are 6a Newton meters since clockwise, no? Clockwise this way. For this you get 5 marks, for this we get 5 marks. Right. That's the end of the discussion.